Hello everyone, and welcome to the first lecture of our Python course. And in this lecture, we are going to discuss all of the basics that are required for someone starting out uh, as a computer science student. So, we are going to cover the fundamentals of computer science. So, what a computer is really, the underlying mechanism, how it stores data, uh, how computer works, and why do we write programs, and why do we need different languages, and how those languages work, and how they get processed, like compiled and interpreted. And we'll get back to Python, what is Python and why Python, and comparing with other languages. So let us start with what a computer is actually. So if you just keep the software like a computer has, so let me take you to the drawing. Yeah. So when you talk about a computer, what a computer is exactly. So the computer contains, let us assume this is our desktop. Okay. So what does it have? The first thing that we have is with a computer is we have its hardware, and we have its software. A computer has hardware and software. In the hardware, we have all the mechanical stuff which we can touch and feel, like what? The screen, the keyboard, the stand, or maybe the webcam, the mouse, the microphone, and etc. These are the hardware that we can touch and which are mechanical. And the thing that makes them work, the thing that is the underlying mechanism and which give instructions, is software, right? So for software, these are instructions, right? So for the software to run, we need to instruct the computer, right? So we will come there, how we will instruct. This is a basic idea of why we interact with the computer, but how? So what exactly? First of all, you just started with computer, you went to hardware and software, you're rushing. Yeah, I know that I'm rushing. This is a basic idea. So first of all, let us get into the computer stuff. Give me a second. Let me erase this. Yep. Let me take this down. Yeah. Now, so if you look at this diagram here, what is the basic, like remove the software, and remove the reasoning behind the software runs, just assume. So what does the computer do? Computer deals with data, right? What is data? Data is nothing but information, right? Data, I'm sorry. Yeah. Computers deal with data. They store data, they take input, they take out, they give output, and meanwhile they may transform it, and etc. This data may be of different types. It may be of text, it may be of photo, video, it may be of different types, right? It depends upon the extension. Different types of data. So it manipulates data however we like, right? See, it holds information, shifts it around, and if we want, we can transform it, right? It can store data. It can store data. So we can, as we know, we can instruct the computer to do something, right? The main important thing here is, we're not talking about artificial intelligence or anything very new, right? We're talking about a simple computer. What does it do? It follows your instructions. So for example, let us take an example. You instruct a computer to put peanut butter on the bread, right? You said put peanut butter on the bread, right? What does it do? What it does is it takes the Nutella jar and puts on the bread. That is right. According to its instruction, it is right. It took peanut butter jar and has put it on the bread. So what I want to say is a computer is a machine which does exactly what you have told it to do. The keyword is exactly. Exactly what you have said. Exactly. So it is dumb. It is a machine and it does exactly what you say, and only and only exactly what you say. So you must be aware of what you're saying and you must be clear of what you want the computer to do. And that is why many people have bugs and all. I mean, errors of what you deal with the computer. So a computer never works out what you meant. What you meant was your inner feeling. You know that. You know that. You know what you meant. That is your inner feeling. But it does not, a computer does not think subjectively. What is subjective? It is thinking with what you meant, like what you feel. Subjective comes with feelings. Computer thinks objectively. What is there, what is real, what is reality. Objectively, it thinks objectively. So you need to be thoughtful of whatever you command the computer. So now what have we done till now? Computer has a hardware and software. Hardware is the mechanical things which it has, and software is the underlying commands or programs that we write for the computer to run, like to fulfill its tasks. And then I mean, we also know that the computer takes the tasks from the commander and fulfills it, right? It is a soldier, but a lazy, not lazy, I mean, dumb soldier. It is not lazy, okay? It performs anything. It is relentless, restless, but never lazy, but also dumb. So, you have to be cautious about what you're telling your computer to do. So, now, as we said, computer can store data. It can store data, right? Computer can store data, but how, right? So if you have heard before, computer stores data in binary format. Binary. What is binary? Binary is zeros and ones. Okay, it doesn't make any sense, right? How can a computer store its data only in zeros and ones? How can it store photos? How can it store videos? How can it store, like, how are we playing games? You have a pure virtual reality inside a game. You can see people, you can do video calls, you can do a lot of things in the computer and in our technology. And you are saying all of this data is just zeros and ones. Okay, I too had this doubt till I have done some proper research to teach you this, to be honest. So I'll let you into this. So give me a second. I'm sorry. Let me erase this. So let's take a scenario, a real life scenario. For example, you're on a highway. Okay, you're on a highway. This is your highway. You're on a highway. Um, and you have a task. Your task is that you have to count all the number of vehicles. Okay, you have to count all the number of vehicles passing through the highway for maybe 1 hour of time. Okay, 1 hour of time, and you need to count all of them. So if you have to count, you just can't remember, right? There may be thousands, there may be hundreds, there may be like a lot of vehicles passing through that highway, because it is highway. Assume that is 8 lane highway, 8 lane highway. Then that is though like very hectic for you to count. So uh, I have like 10 fingers on my hand, right? 10 fingers. Do you assume, like, can you count that? You have 10 fingers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? You have 10 fingers. Assume that you have 10 fingers. If you count, one car passed away, two cars passed away, 3, 4, 5, 6, 7, 8, 9, 10. 10 cars passed away and your hands got filled. So you can count only 10 cars using your fingers, right? Um, okay. If you use something smart, so whenever there is one car, you count it here. Whenever there is a second car, you just close this finger and just open this finger. That is the second car. You will count it 2. Whenever there is a third car, you will open this, doing at 2, doing as 2, and also open this again, saying it 3. Right? You're getting me? Next, when the fourth car passes, you'll open this finger and close these both. So what you're doing is, whenever there is a new car and filled up with your old fingers, you will open a new finger. This simply means that we are opening our fingers in the powers of 2. In the powers of 2. How? Let me explain you. Let me erase this. Wait a sec. Right. Okay. Okay. Uh, wait a second. Wait a second. Wait a second. Okay. Yeah. So now we have, assume that we have 4 fingers, right? Assume that we have 4 fingers. 4 fingers, right? Right. So this is 1, and when you get 2, you close this, open this, and close this. 1, and when you get 2, you do this. When you get 3, you do this. When you get 4, you do this. When you get 5, you open this. When you get 6, what do? This is just a game of permutation and combinations, right? If you know P and C from your 12th, in the 12th math, you can understand what's happening here. So the underlying mechanism is that everything is a power of 2, right? So if you have 4 fingers, there are possibilities. Like, if you have only 4 fingers, you can count only 1, 2, 3, 4. 4 fingers, right? 2, 2, 2, 2. 2 power 4 possibilities. How did I get this? I'll explain. So when you have 4 fingers, you can count 16 cars. How? Let me explain. In P and C, permutation and combinations, if you remember, see, this finger has 2 possibilities. Either it can count or it cannot. It can or it can't. It can or it can't. It can or it can't. So everything has 2 possibilities, right? Right. And when you are counting, all these four fingers are dependent. In PNC, dependent gives you multiplication on your solving problem, and independent gives you addition. When we are counting, all our four fingers are interdependent for counting the numbers, for counting the cars, so they are dependent and we multiply them. So if you take a more smaller number, like maybe two fingers, how many cars can you count? You have two fingers. Okay, first initially it's 0, like it's closed. Okay, you count 1. Good. For 2, you open this and close this, that's 2. So one car, 2 car. And for 3, you open both, so you can count 3 cars, right? So how many possibilities did you get from two fingers? It can either be closed or open. It can be closed or open. It can be closed or open. It has two possibilities. It has two possibilities. This finger has two possibilities, and this finger has two possibilities, and they both are dependent, because see, every possibility has both the fingers, right? They are not independent, they are dependent, because every possibility has both the fingers, right? So we need to multiply them. 2 into 2 is equal to 4. This is the zeroth car, but that is also a possibility, right? An event that which can occur. So these are 4 possibilities, and we got 4 possibilities. Like how? See, when the finger is closed, and this can be closed and open. When the finger is open, the other finger can be closed and open. So that's 4 possibilities. In the similar way, when we have 3 fingers, this can be open, and this can be open and close and open. So here we'll have 2 possibilities. Next, this can be close and the same, 2 possibilities. Here we have 4. Next, this can be, like similarly, in the same way, if you count through PNC, we will get here 8 possibilities. So if we generalize this equation, so in the same way, if we generalize this finger can be open or close, that's 2. The second finger can be open or close, that's 2. The third finger can be open or close, and that's 2. 2 into 2 into 2, that's 8 possibilities. So if we have 3 fingers, we can count 8 cars. So similarly, a computer stores data in the form of 0 and 1s, where it will store in zeros and ones of different possibilities. So the data that you see is a multiple, always a multiple, a power multiple of 2. This answers your question. You've seen, right? If you see the memory of your any device, it will always be in 2 powers. Did you notice? I used to always ask this question: why is my RAM 8, 16, 24? Why is my computer's RAM 64 GB? Why is my mobile phone's ROM only 512 GB? Right? If you can see, if you ever thought of this question, why is my storage only 512 GB? Why not 500? 512 is a power of 2. So that's I hope you were if it was new for you, so you have learned something new, then drop a like. So next, we knew that computers store data in the form of zeros and ones, but still, what are these zeros and ones? Why zeros and ones? You said computer could not understand our human language. Obviously it cannot understand human language. You say, hi computer, will it understand? No, it won't understand. Then how is it processing? How is it, like, how are we able to communicate to it? We'll get there. So 0 and 1s it won't understand. So these are not zeros and ones. These are actually, imagine there are bulbs. There are bulbs. So when you say 1, there is voltage being supplied to this bulb, and that is glowing. It is true. True means yes, I am glowing. True. Yes. 0 is false. Bulb is not glowing. What is this? This is hardware. A computer can know hardware. I mean, it is computer is hardware, so hardware is working, right? So, what will computer do? If a computer sees a bulb not glowing and a bulb glowing, that is a possibility. Both the bulbs glowing, that's a possibility. Both bulbs not glowing, that's a possibility. And right side bulb glowing, left side bulb not glowing, those both are, I mean, one glowing and one not glowing, that will be of two possibilities, right? And both glowing, both not glowing, one glowing on the each side, that's four possibilities. So it is of bulbs. We have 3 bulbs, 4 bulbs, 5 bulbs, like that. We can increase the number to anything we want, and that is how data is stored inside it. So I know you still would not get clarity on this. I know. Let me, please give me some time. You will get some. You will get everything summed up at the last, right? So now you know that uh, a computer stores data in the form of zeros and ones, which are the bulbs. So to be more accurate, those are not bulbs. Those are capacitors, right? Those are in the hardware. Those are capacitors. What are capacitors? Capacitors are a device which stores electricity for some time. I mean, which stores charge. I'm sorry, which stores charge for some time. It uh, stores charge for a minimal amount of time. It charges and discharges very easily. So when a capacitor is charged, it is 1, it is true, or bulb is glowing. Or when a capacitor is discharged, or the charge is left out of it, it is 0, it is false. It is yeah, it is 0 and false. It is discharged, right? So how does it interact? Like how do we transform it to the computer? Just like how bulbs are attached to switches, like to know that if it's on or off, we need switches, right? In the similar way, for the capacitors to charge and discharge, they're connected to transistors, which will tell us whether it's 0 or 1. So now that you know that the computer will get its data in the form of charge and discharge, i.e., that is 1 and zeros, ones and zeros, and it stores data. So zeros and ones can be in any form. So we know that it is 0 and 1s. So the next level, each one and zeros are each known as bit. So this each digit is known as 1 bit, right? It is known as 1 bit, and 8 bits are equal to 1 byte of memory in the computer. I'm sorry if you are getting any background noise of dog barking. I'm very sorry. Okay, 8 bits is 1 byte of memory. Okay, so in the similar manner, these bytes make up to our memory. For example, if you talk 1 KB of memory, that's 1 kilobyte. Actually, it's 1 kilo is an approximate number. It is 1024 bytes of memory, right? 1024 is of course a power of 2 power n. It's a power of 2. 1024 is a power of 2. And so now we know that the memory is of bits and bytes, and it's of power 2, right? Now So now, okay, you know that memory is of bits and bytes, but how? Do you want to know the mechanism? So let me dive deep into that. So what are our let us go get into the data types. Like, how do we store data? We store it in the normal text form, right? We store it in the text form. We store it in pictures, photos, and it has many different types maybe. And we store it in videos, etc., right? So let us get into the text. What is text? Text files and all. What are stored in text? Like characters, right? Characters. So characters, alphabets, numbers, symbols, right? That's it. So if you look into the characters, look at all of them. Alphabets, small alphabets 26, capital alphabets 26, numbers, I mean digits, maybe 10, special characters, question mark, less than, greater than, comma, parentheses, brackets, and all of them. Even if you mix all of them, maybe you'll get 190, 180. I don't remember the exact number, but you'll get about 180 to 190 or 170 in that range of characters. I mean, characters. So if you assign a unique value to each character, can it store the data? Right? Just think about it. So for example, we have all of these characters. If you count all of the characters, all unique characters in this world, alphabets, digits, small alphabets, big alphabets, symbols and all, if you count all of them which you can type through your keyboard, they will not be greater than 200, right? They will not be greater than 200. So they are less than 200 or something, 200 something. So if you assign a unique value to each character, you can store them in the form of data, right? So for example, they will be less than 200, right? So what is 2 power 5? 32. 2 power 5 is 32. 2 power 6 is 64. 2 power 7 is 128. That is still less than 200, right? 200 or 180. 2 power 7, 5, 6, 7, yeah. 2 power 8 is 256. So our desired number 180 or something, I told you, right? 180 to something characters. So 180 is between this, and we can't, of course, we of course can't take less, so we'll take more. So we will take 256 possibilities. We can take in 2 power 8 we have, what is this 2 power 8? Here 8 means the bits. Why? Yeah, these are bits. These are the possibilities, right? So if there is a 8-bit number, 1 2 3 4 5 6 7 8, 8-bit number, here we can store, for example, we want to store, so okay, yeah, let me get into this. So yeah, these are 180 characters, right? So they can be stored in 256 possibilities, right? 256 characters can be stored in 2 power 8. So we chose this as the standard memory for a character. This leads to the we will get later into this story what is the memory of each data type. Like in the standard programming languages, they will say for integer it will take about 4 bytes, but for a character it will take 1 exact byte. Why? You have the reason, my friends. You have the reason. Because all the characters made will be less than 256, will be in the range of 180 to 200, and we have to store data in the forms of zeros and ones, and the closest greater tooth power was 2 power 8, and this being the standard size, they have decided to make the 8 bits Why not 6? Why not 7? Why not 10? You should have gotten that doubt. I have not mentioned earlier, but why only 8 bits is equal to 1 byte, right? This was the underlying reason. Okay, 8 bits is equal to 1 byte, and 1 byte is the exact memory needed for a character. What is a character? Anything that you can type. Okay, so now you can assign a unique code, a unique binary code for each character, right? For each character. So this process of turning your natural characters into unique binary codes is how memory is stored inside the computers, right? I hope you have understood a greater lesson from today. And what now we can do is, so you can put that in any way. So for example, you have a, for example, small a or big a. Let us assume we have big a, capital A, and you have to assign a unique code to this, right? And we have 8 bits of storage, 1 2 3 4 5 6 7 8. You can assign, if you assign this, tell me what is this code, tell me what is the value of this number, binary number, tell me. If you see, this goes into the 2's powers, right? Each place corresponds to the weight of 2 increasingly, right? I don't know if you know these basics or not from 12, but I'm sorry if I was rushing. Okay, 4 5 6 7, so 8 bits. This is 2 power 3, that's 8. So by this example we have assigned A's unique value as 8. The computer won't take 8. We are just finding out the value from the binary code. If we want to know the value, it takes like this. So like this, in way, every unique character will get a random a random choice of the zeros and ones, a unique permutation, and that unique permutation will have a unique value, and that unique value will be its unique number or code for that number. So a standard way for this notation, like, see, I have assumed this, see, and some other guy who will teach in his lecture will assume he may change the 0 0 0 0 1 0 0 0 to 1 here, or maybe 1 here, or maybe 0 here and 1 here. There are 2 power 8 possibilities. So yeah, right, here 2 0 or 1, here 0 or 1, here 0 or 1, like that. Here 2 possibilities, here 2 possibilities, here 2 possibilities, here 2 possibilities, and those all are dependent, right? Those all are dependent, because we can't get a number if we get rid of this, right? Those all are dependent. So we can get 2 power 8 possibilities. 2 power 8 was 1024, or how much? No, I guess I have said it was 64 or something. Yeah, I don't remember it properly. Okay, leave it. We can get those many possibilities. So that is why there is an international standard for this values, where each character is assigned with a unique value. All right, and that unique value, the most standard one which I know, is ASCII. It is known as ASCII values. ASCII values. Let me just show you the full form of ASCII. And see, American Standard Code for Information Interchange. See, first thing, it is American. It shows that it is done by Americans. Standard, that means it is followed by all over the country's code. It means the unique code which is assigned to each character. For a unique code is assigned for information interchange. When we are interchanging information between the normal to binary, for interchanging information we have a standard code. All right, again I hope you can understand, and we'll have a table for that. You can see let's see a random table. See, as I said you, wait, this is not so good, I'm sorry. Yeah, yeah, as you can see here we have 177 of these unique characters, right? Like that. In the same way we have assumed that there will be 2 power 8 vacancies for a ASCII code. So next, let us get into the next thing. So now we know how computer saves okay, welcome. Okay, now we know how the computer saves data in the form of text, right? So let us see, for example, if you have my name Praveen, my name is Praveen, by the way. So if computer needs to save this, right, it wouldn't save this as Praveen, right? You know now how it saves. So if there is Praveen, how much memory will the computer allocate, right? I'm asking you this question. If the computer needs to save a text file or a text which is Praveen, how much memory will it consume, right? For P, it will take 8 bits, 1 2 3 4 5 6 7 8, and in the 8 bits it will store the ASCII value or anything, its unique code of P. It will have a number. For example, let us assume something, let us assume this much. So in the same way, so this is 8 bits, right? So this is 1 byte of memory, right? Similarly, for every character there are 8 bits and each has a bit, right? Byte, each has a byte, right? I'm very sorry. Every character has 8 bits and 1 byte, right? In Praveen, how many characters are there? Praveen. 7 characters are there. 7 characters. So it will consume 7 bytes of memory. So now you know, my friends, how much memory it will store for a file in text format, right? Which has characters. So I'm sorry. Now let us look into pictorial memory. How does it store pictures, right? So if you look into any picture, what you'll notice is the quality, right? You will see 1080 by 1080 or 1080 by 1920, or what is this? The first thing is resolution. Second thing is aspect ratio. See, the aspect ratio is very simple. It is the height by width ratio of the picture you have, and it will just give you the, like, if it is taller or broader, or it is just equal if the height by width ratio is 1. That is aspect ratio. But how is height and width being measured? Is it centimeters or millimeters or nanometers or somewhat like that? No, my friends. What you see in pictures, you need to know this. This is very interesting. I'm sorry, wait a second, I'm sorry. Yep. So every picture is a formation of infinitesimal pixels. Picture, pixels, small equal squares pixels, a huge picture is formed from infinite, I mean it's not infinite but infinitesimal, many small pixels. So when you meant 1080, that means there were 1080 pixels lined up right here in the height. And if you meant 1920 here, this is height by width ratio, there were 1920 pixels right here. So now each pixel is the smallest amount of data present here. Let's take to the pixel. In this pixel, so for example, there is my face right here. Let us produce a random image. Let us see a random image. I'm sorry. Let us search for a random image. So for example, we have this potato right here. See, okay, when we have this potato right here, there are infinite pixels, many pixels inside here. See, if you see here, can you I hope you observe it here. See here, I don't know if you can see. Yeah, if you see here in the right corner, it says 1500 cross 1600. That means in the height there are 1500 pixels and in the width there are 1600 pixels. 1500 cross 1600, right? So when there are 1500 pixels, I'm very sorry. See, when there are 1500 pixels, each pixel carries a color. So when infinite these many small pixels each have a changed color, you see the overall image in your device. Understand? So, and how this pixel is storing color? You may have this doubt. Computer to understands zeros and ones, right? Discharge and charges. And how did you go to colors? Each color has a unique code, right? It is also stored in 1 byte memory. Each pixel is of 1 byte memory. But how does different images have different resolutions? Same again, the number of pixels change. How small the pixel changes, how many pixels you insert into the same height. Like, I mean, if there is this much of image and you insert many more small pixels, the quality of course increases, right? You capture the most and smallest tiniest details by dividing them into infinitesimal pixels, right? So resolution grows by dividing the image into more and more pixels. So when you say 4K, why does 4K have so much quality? Instead of 1040 pixels, we have 4000 pixels. So the clarity and the details are captured by more and more tiny pixels. And that is why when there are 4K pixels, there are 4000 bytes of memory. 4 KB into, if you have something here, so that's 4 KB into that much of memory. That, my friend, is how an image is stored. How an image is stored in a computer, how the picture is made, how the memory of a picture is calculated at the deepest root level. Okay, so now what about a video? If there is any person who is enthusiastic towards video editing or videography or anything like that, or photography, you should have, if you are into photography, you should have known this by now about the aspect ratios and how the image is formed and how the resolution is measured. And let us talk about the video. A video is nothing but a constant movement of many photos, right? A video is nothing but, so for example, you should have heard about FPS. What is FPS? Frame. What is a frame? It is a rectangle or square. I'm very sorry. It is a square or rectangular frame, right? Per second, how many pictures per second play? That is why if you have 120 fps, that means there are 120 pictures being framed every second. They flow in a speed so that our eyes can't capture that blink, and they appear to us as a video. They are photos being played continuously disguised as a video. I mean, the definition of video itself is that photos play at a speed. For every second there are 120 photos being taken by our camera, right? So now you understood, my friends. So if you take a video, that means a picture into a picture, I mean add the memory, right? A picture. So for example, we have a 4K photographs video. I mean, the if the video resolution is 4K, the each photos resolution will be 4K, and the memory, this is the height and this is the width. So this into maybe this is 120 fps, right? So per second it will be 4000 into the width into the 120. This much memory is accumulated or used by the computer for 1 second of a 4K memory video tape, right? Interesting. So this is how video is stored in a computer. I hope you have understood a very beautiful representation of how memory is stored deep inside our computers. Okay, so I think we have covered most of the things that till now. Let us check. So you know what computer really is. A computer is a machine which is made up of hardware and software. It is a dumb and logicless. We provide it instructions. It is just a slave for us. It has no self thinking. We are not talking about artificial intelligence or something new. We are talking about a random machine, right? It has software and hardware. Software is the code that we're going to write. We will come into it in the future. And next thing, everything is numbers and numbers are switches. Everything is numbers. Everything is in the form of 0 and 1. Every 0 and 1 is just off or on, true or false. I mean, off or on. Off or on is either you call it a bulb or you call it in the most deepest level as a capacitor being charged or discharged with a switch as a transistor, giving it a signal to the computer that if it is charged, the transistor gives a signal to the computer that it is true, and in that way we can store in the form of memories in the powers of 2, and everything, my friend, from text, from photos to images, is done by the numbers. Crazy. We have come till there, and we have what is a program and why do we need languages. Let me come there and let me just finish the okay, let us come back. Okay, we have finished text, photo, video. How are games made? Games are nothing but photos and videos combinations. They all are combinations of this only, photos and videos. So the most discrete things are characters, photos and videos. You got the idea of them, and anything is just a combination of them, and you get different types of combinations, right? So next, okay guys, let us get into the what is a program and why do we need languages section, and then let us discuss about the upcoming parts in a flow. So let us go into, so what is a program? You hear people talking about programming. So what is program? Program is nothing but I'd like to compare this with something in real life. For example, you want to make tea or coffee, anything you want, anything you like. So I'm assuming you want to make tea. So to make tea, you need a set of steps, instructions, right? First, take some a container or a kettle, take some water, boil it. So you write some steps to get our byproduct tea, right? In the similar way, when you need something, an output from your computer, to instruct it, you write programs to get what you want, to interact with your computer. We as a humans, we provide programs to the computer to get our output, right? And a program is nothing but it is a set of instructions written by humans to instruct our computer, right? So program is nothing but a set of instructions. Program is nothing but a set of instructions. Now, so we are talking about instructions. So we have to instruct to the computer. Instruct to the computer. So Praveen, till now you have said zeros and ones and zeros and ones. Now you are directly talking instruct to the computer. There is something off, like there is a gap between this. Again, you are not explaining properly. Yeah, let me get to it. So the main thing while instructing a computer is computer though understands binary language, machine level language, but we speak English or we speak human language. So there is this gap. This is where programming languages come in. This is why we need programming languages. The name has the answer. Programming languages. What is language? I'm sorry. What is language? Language is a medium through which different people can communicate. And here it's a programming language. There are different languages in which we write programs through which we can interact with a computer. Here it is computer. Okay. But do we write programming languages in zeros and ones? Do we need to write all 001001 110 like robot? Do we need to write like this to learn programming language? No. I mean, you can. It is known as machine level coding, machine level languages, and people are there who genuinely understand machine level, everything in machine level, and that's too much unnecessary. Unless if you are too enthusiastic about how the machine level commands work and everything, if you want to do everything in machine level, that's some other kind of jargon, and we don't need to get into it. So the programming languages, so we know English, human level language, English. We write something closer towards the English as a programming language in characters. That is sent, and we need to do it into machine level zeros and ones. So in between, people in the 2000s and all, they have 19s and 2000s, 80s, 90s and 2000s, they have made their contribution into the computers, and they have made something as a translator which translates between our English level and the machine zeros and ones, which converts this English level programs instructions into direct zeros and ones, which is known as our translator. This translator is later called as, you keep names to it, as interpreter, compiler, or anything. This is assembly language. In between we call this as assembly language or something like that. This is machine level languages, machine level data, and this is high level languages. High level means closer to humans language. Low level language means closer to the machine level language. Machine level, assembly level, and English programming language. So Python is a high level language. Python is a high level language. C is also medium level language to high level language, because obviously it is not low level language. Some people call it low level language because it directly deals with the memory of machine language, but you need to understand the context in which they're speaking. They're saying low level memory management language, right? It's not about the instructions. See, it does need any language that we write in the modern era, any programming language that we write needs a translation, and it needs to be parsed and compiled or interpreted, right? The code needs to be processed into something machine level, into zeros and ones, right? Okay, now you know computers, how to interact with them, how the data is stored and all, what is a program, why do we need to learn programming languages, why do we need to learn programming languages? To give instructions to the computer, and we can't give them directly, so we need to learn a medium to interact with the computers, and that is not of course machine level and assembly level. We can do something closer to English, and that is the easiest possible thing. Machine level and assembly language aren't that easy as compared to the high level languages, right? And you may get a doubt, then okay, we have different programming languages. I mean, we have a programming language, but why different languages? Why different languages? It always comes to the same thing. If you have a Lambo, and if you have a van or a bus or a public transport, or let's change it to public and private transport. Public and private transport. In private transport, you can have comfort, you can have family, in personal time, and you can go quickly wherever you want. Sometimes, I mean, it's subjective, like sometimes you have traffic and you can't go quickly, and here you don't have traffic, you just go on metro or something. Just leave it to like that. Here you don't have comfort, discomfort, I mean generally, and everything. So everything has trade-offs, right? Every change in this world has something has disadvantage and something has advantages. Like there are trade-offs between options. So there are advantages in some languages and disadvantages in some languages. In some languages it is nearer to the computer's memory, and some languages are easy to code and like that. So there are different languages. So sorry, how is code parsed, right? We are saying that there is a translator between the human language and C. Okay, let me show this to you. If you see here, see what the processor speaks is, see, 0 1 1 0 0. This is each a byte, right? 1 2 3 4 5 6 7 8. This is each a byte. It speaks in bits and bytes. Okay, so this is unbearable for humans. We just can't do that. We just can't understand that normally. And this is what we can write. You know, see, you can understand if age greater than or equal to 18. Okay, print adult. We can read all of this, right? Colons, parentheses, and we can read all of this, right? So we learn these programming languages which interacts with the processor. So there's a gap between this, and that brings, as I said, the translator. Your idea in readable, human readable code is converted to a translator which directly interacts with the machine numbers. So this translator can be of different types, generally of two types. It can be compiled or it can be interpreted. What is compilation and what is interpretation? I don't know if you can say that. Okay, what is interpreter and what is compiler? A compiler reads all of your code at a time and transfers it into the machine code in a single time, and it then issues with your, if there are any, it issues with your errors or any difficulties faced during the compilation. What is an interpreter? Interpreter goes So you wrote a program, for example, let's assume your code is of 5,000 lines and you have instructions, 5,000 or 2,000 instructions. So it will compile all of the, it processes all of the instructions at a time, and then informs you about the mistakes or anything. But about the interpreter, it goes by line, it goes in an order, it interprets each line, each instruction, and immediately tells you if there is an error. See, but if you can observe, a compilation goes very quick, all the files, all the instructions at a time. But the trade-off is the errors are late and you need to fix them later. But the interpreter, it runs very slow as it measures everything. I mean, there is another underlying reason why it is very slow. Interpreter, that will be, I'll be explaining that later. I mean, generally people say Python is slow because it measures line by line. That is not so reasonable. That is not so reasonable. I'll tell you the real reason majorly why it might be slow than a compiler. And let me just continue with this. Yeah, so it goes line by line and it immediately tells you the error, in which line you have the error, in which command or which instruction your logic has failed. So that is the two ways you can do your parsing or processing towards the machine level code, right? So now, what exactly is Python? What exactly is Python? So I hope you understood compilation and interpretation. Yeah, okay, let's continue with the remaining part. So when we talk about what is Python actually, people they don't know the proper meaning about what they're talking about when they say Python. Okay, when you say I'm writing my code in Python, or when I'm writing a code in the extension of the file as .py, Python, is that you're talking about the language. You're writing the code in language. It is about the grammar, the vocabulary, the syntax, the code you're writing, defining classes, objects, writing functions, writing your code, and everything defining. It is the language. It is how you describe it and how you write your programs. It is how you write your instructions to the machine, right? There's another thing, when you say install Python in your system, install Python in your machine, that is known as the interpreter. So the thing about this interpreter is when you complete writing your code, the thing that translates it to the assembly code, I'm not talking about the machine level code, I'm talking about assembly code. There's this thing called assembly code. See, when you're writing in C, it directly goes from assembly, your English code, to assembly to machine level zeros and ones binary format. The thing with Python is that the Python itself is written with C to make it easily accessible with syntax. You know what I'm talking? So Python is itself coded in C language, and that is why many people argue that C is the god and C is the father of Python or whatever whatsoever. So we don't need to argue with them. The fact is that the interpreter works on C language. So that is why it's generally called as C Python. So the interpreter is called C Python. I mean, one of them, if or not, I don't know. C Python. It converts your Python code grammatically. It checks the grammatical and if there are any, it checks for the bugs, and then it transforms into the assembly C code, C Python code, and then it's done to the parsing and fetching and all. So what's the process? The process looks like you write your code in the plain .py extension. Like whenever you write your code or whenever you do something, see, you have data. How does the computer know how to parse it? Like how to know, how does the computer know what type of data it is? So if it is a photo, we knew that it would do like this. If it was a normal data, it would store data like that, no? So the computer needs to know what type of data we are giving it. So we define an extension so that the computer can know what type of data it is dealing with. So for example, here we always put the extensions in the file name and then .py format. Did you get it? We do it in the form of file name dot the extension. Here it is for Python, it is py. For other languages, for example C, it is C. For C++, it is also another programming language, it is CPP. CPP, right? It goes like that. So you write your code in Python, and the interpreter parses it, converts into C Python. It checks, it fetches many times. It then goes to the bytecode. I'm very sorry. See, the real processor works. The interpreter is basically fetch it, decode it, execute it. This happens a millions of times, and that is why Python is slower than C. At the center of Python there is basically a giant loop. Then what codes is doing millions of times. This is why Python runs slower than C. Did you get it? As there are this extra step in Python than C, and this extra step is fetched multiple times. As you see it, the interpreter goes line by line, so it fetches multiple times, executes it multiple times. After each line there is an infinite loop inside this C Python extra step, and that is why C is quicker and faster than Python. Do you get it? That is the reason, underlying reason why C is quicker than Python. Alright, so you've discussed what actually is Python. You know now the difference. When we talk about Python, what are we talking about? Are we talking about the language? Are we talking about the interpreter that is working underlying to change the code into C Python? Got it? And now we are discussing at the last why Python and Python versus other languages. We'll be discussing it right now. Let me take you to this presentation. Yeah, why Python? It is mostly like English. If you look at C, C++ and Java in the future where you'll be learning them, it is a little difficult when you talk about the syntaxes. I mean, all of them are high level and all of them are closer to the English. But when we talk about the other syntaxes of the syntaxes of the other languages, they are little more symbolic. They are more about stricter about the syntax, about the brackets, placements, and all. But in Python, it's very close to English, a little more close than the other languages, and very little. Like the syntaxes are very simple, and it has many libraries and uh, many libraries which are useful for the AI and data science and everywhere. And of course it is friendly for the beginner. It is beginner friendly, and when we compare it with other programming languages, it is, of course, as we said, it is clear English and readable for automation. um, it is a bit slow. I mean, as I said, there are always disadvantages for the advantages you take and advantages for the disadvantages you bear. So yeah, it's that way. If you want to know about how the other languages look like, see, JavaScript is used for mostly for the web development and all, and Python is also useful in the web development. It is also useful in the AI fields, in automation and data. It is used in finance, it is used in quant, but it is just a little not advantage in the where speed and security matters a lot. For security, you will be taking about Rust, which is a very secretive coding language, and for speed we generally take the C and C++ as it directly accesses the memory of the machine, right? So I think this is it for the first lecture of our course, and I hope you have learned something new. I'm very sorry if my voice is low or bad, and I've been affected with cold actually, and I don't know if my teaching was good at all. This is my first time teaching a lecture online, and I guess this is it. Thank you. Let us meet in the next lecture, lecture 2, which will be rolled out tomorrow maybe. Okay, thank you.